Hello students, welcome back to Organic Canvas. Today I'm back with one more interesting organic chemistry question wherein you have to find out what is the final product for the given reactions. As usual, we will first find out what are the functional groups present in the molecule. There is an aromatic molecule attached to a functional group amide. Remember CONH2 is amide. And what is this amide called as? It's a benzene amide. Now, at ortho position, we have ethyl group. So, you can call this as ortho ethyl benzene amide. When this is treated with bromine in presence of sunlight, the H nu refers to the sunlight. Students, remember, whenever the bromine is taken in sunlight, this reaction mechanism is through free radical mechanism. What are free radicals? These are the reaction intermediates formed during the course of reaction by homolytic fission of a bond. What does that mean? You know that a covalent bond is formed from two electrons. If each of the bromines take one electron like this, we are going to get reaction intermediates, bromine free radicals. We use fish hook arrows to show that it is through homolysis or homolytic fission of a covalent bond. Now, since it is free radical, it will undergo free radical substitution at the alkyl chain. But we have two hydrogens here, we have three hydrogens here. Where the hydrogen will get substituted, the free radical substitution always happens at the benzylic position. What is benzylic position? The carbon which is attached to the benzene ring. So what happens is when the benzylic free radical is formed like this by removing one hydrogen from here. When we get the benzylic free radical, it will undergo resonance through the benzene ring and it will get stabilized. Hence, we are going to get the free radical at this position only. Then what it does, it's going to interact with one of the free radicals here and the bromination is happening at the benzylic position. So we are going to get a product like this. I'm writing a bond line structure for the same molecule. You can see here, this is CH, CH3, Br is present. Within the molecule, we have two reactive centers. One is amide, the other one is this electrophilic carbon. And you see we are using KOH also. That means what? It will abstract the acidic proton from here and it's going to form a negative charge on the nitrogen like this. So since it is electron rich, it will attack the electron deficient carbon. Bromine is a good leaving group. It will leave the molecule. So this is a substitution reaction and the cyclization is taking place as cyclic products are more stable. So this is a classic example of cyclization. This is intramolecular nucleophilic substitution reaction and we are getting a cyclic amide. And cyclic amides are called as lactams. Students, I am giving you one more tip here. The cyclic amides are called as lactams and you can name these lactams depending on the number of carbons. Say for example, when this CO carbon is attached to this carbon, we call it as alpha and this is beta and this is gamma. Since gamma carbon is attached to nitrogen, you can call this as gamma lactam. So 5-membered lactam is called as gamma lactam. So this is the final product for our reaction. Check where do we have in the options. This is a secondary cyclic amine, not possible. We have a lactam, but it is 6-membered, so not possible. What about here? This is 5-membered, and you can also see the methyl as a branch. Hence, our final product is as shown in option 3. What about 4th? This is not a lactam, so you can eliminate this also. So students, now you have seen how to make use of the basic concepts of organic chemistry like homolytic fission, stability of the free radical, and nucleophilic substitution reaction to solve this particular question. If you still have any doubts on this, please ask your queries in the comment section. And I have included a question at the end of this video. Please do solve it because practice makes perfect. Thank you for watching this video. Until next time.